Alrighty, y'all, Mr. Montana here. We're going to get started. This is the test one review. This is going to be a rather long video. We are going to try and power through this as quickly as possible. Okay, so question 1 says, what is the name of a ray on the plane? Alright, so on this we have to remember what a ray is, okay? And so I would highly recommend drawing out your words again as they come up. So a ray, we should remember a ray is a point, an endpoint, to an arrow. All right, and it's always going to have usually a second dot on it for naming purposes, but looking at this, we need to look. So we can clearly see that C to A is a ray because it starts at a point and goes to an arrow. All right, so we can call CA our first ray, and we must label that as C to A because we always start with the endpoint when naming a ray. There is one other ray that may be a little more difficult for you to see, and that would be ray AB. And so ray AB is also another applicable answer. Now it says, what's another name for line? And then it gives us a cursive P. And so line, right? Our line is going to look like 2 arrowheads on either end. All right, and so in order to name a line, we have to remember that we only need 2 points on that line, and the 2 points given on that line are going to be line BA, or we can name it in the opposite way and name it AB. All right, and so it's important to understand that that notation up top with the drawing of the line above it makes a huge difference, because if we look at question 1, AB is also a name of a ray. All right, so we have to make sure that we're being intentional. Now it says, what's the intersection between a line and a ray? So we've already named out our rays. We said we have CA or AB, and then our lines we have BA and AB. So I'm going to go ahead and highlight our line in blue right here, and then our ray here in green. All right, and so we can see that those clearly are going to intersect at a point, and it is going to be point A. It's the thing that they have in common. All right, so for a point, y'all, we need to remember that it's just represented by a dot. And then now it says to name 3 points that are coplanar with point A. And so we are looking at this point right here that I just colored in yellow. And so what we have to remember is for something to be coplanar, it cannot also be collinear. So we need 3 points that fall within that same plane. And so I'm going to go ahead and go with F, C, and B. All right, we cannot use D or E because they fall outside of that plane. All right, now looking at question 5. Question 5 says, find the length of UV. And so we can see that we are given the total here, right? We are given all the way from U to W. Then we're even given from V to W. And it wants us to find U to V. All right, that green section right there. So now if I begin to do this, I'm going to realize that this is a part plus part equals whole question, which is the segment addition postulate. And so I need to ask myself, what's my first part? Well, my first part is represented by AUV plus VW, which is my second part, and it equals my whole thing, which is UW. And now I go and plug in with numbers. UV, I don't have a number, so I go ahead and I keep UV as what it is. Then for VW, I'm given a 4, and that's going to equal my total, which I'm given an 11, all right? And I'm going to go and color coordinate this for y'all. That 11 is the whole, which came from the red section. The first part's blue, which came from the blue section, and then the UV is the green section, all right? And so we're going to go ahead and continue with this, and we need to draw our line. And then our first step is to subtract 4 because we are wanting to solve for UV here. So I mark out, and then I am left with UV is going to equal 11 minus 4, which is going to be 7. So we get that UV equals 7. And then, guys, the most important thing that we have to remember, we have to ask ourselves, is that what the question wanted? So we go back up to our question. Our question said to find UV. we found UV, and we found that it equals 7. So yes, we are done with this question. So we can go ahead and continue on to the next one. All right, so now looking at question 6, it says to find the distance between G and F. And so you can see point G and F are plotted on our graphs, and we need to recall a couple of things. So the first thing we need to recall is our distance formula. And our distance formula is going to be D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And so then the next thing we need to do is we need to be able to label our points. And so let's go ahead and pull out point G and H, because that's what we're working with. So point G is going to be located at -1, 3. And that's because all of our points go x, y. All right, x, y. We need to remember that. And then for point H, we're going to go ahead and plug in. H is going to be at 2, -4. And now we need to go ahead and label our points. And so we need to label our x1, y1, and then our x2, y2. All right. And so I'm going to go ahead and color coordinate. We have our pinks for our x1s and y1s, and then we have our blues for our x2s and y2s. And I'm going to go ahead and highlight in the formula as well. All right. So we should end up with something that looks a little like this, and then we're going to go ahead and continue and work this out. So plugging into this equation, I go ahead and type in D equals the square root of x2. It tells me that it's a blue one, so it's 2 minus x1, which is -1, squared, plus parenthesis y2, which is -4, minus 3 squared. All right, and then we can go ahead and we can plug this into our calculator. We can plug this into Desmos. If for some reason you do not want to do that, we will go ahead and solve this out all the way. And so what I have to remember, y'all, is that when I have minus and negative, I'm really adding. So 2 plus 1 is going to be 3 squared, plus -4 minus 3 is going to be a -7 squared. And then we keep working it down. And so we are left with 3 squared, which is 9, plus 7 squared, or -7 squared, which is going to be a 49. Then we get down one more step. We are looking at doing 49 plus 9, which is going to be 58. And then at that point, y'all, we're going to have to type that into our calculator because we don't know the radical of 58. It's not a perfect square. And we get that D equals 7.62. All right, D equals 7.62. And that is how you solve that final question. Moving over to the back side of this page, we are looking at finding the distance of JK. And so the distance of JK, it's on a number line, y'all. The easiest one is when it's on a number line because all we are doing is counting the spaces. So we have 1, 2, 3, 4, 5, 6, 7. So the distance here is 7. All right. Now it says to find point M is between L and N, and LM is 2y plus 8, and MN is 3y. If LN is 24, solve for y. So the first thing we need to do here, y'all, is we need to draw our diagram. And so we are dealing with something that's going to look like this. And it tells us that point M is between L and N. Then it goes to tell us that LM is 2y plus 8, and that MN is 3y. And then it says to solve for y, given that LN, which is the entire thing, is 24. All right, guys, and then on this question, this is going to be a part plus part equals whole. So I'm just going to go ahead and write it as P plus P equals W. And then we're going to go ahead and plug in, y'all. So my first segment, or my first part, is going to be LM, which is represented by 2y plus 8. So I'm going to go ahead and plug in. So 2y plus 8 plus 3y, which is my second part, equals 24. And so here, y'all, I'm going to want to combine like terms. I know that this 2y should combine with this positive 3y, and then I'm going to get that that is 5y plus 8 equals 24. And then I'm going to draw my line, subtract the 8 over. Then I'm left with 5y equals 24 minus 8, which is going to be 16. And so then my last step is to divide by 5. And I will get 16 divided by 5 is going to equal 3.2. So I now have that y equals 3.2. And the most important thing here is to ask, what was my question asking for? My question was asking me to solve for y. And if I've done so, then I'm done. And luckily, that is what I've done. And so now I don't have to plug back into anything, and I can continue to the next question. Question 9 says, find the coordinates of the midpoint of Q if P is at -3, 1, and R is at 5, -6. And so what you can do here, y'all, is you need to remember your midpoint formula. And so midpoint, y'all, is going to be x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. All right. And so now we have to label. We got x1, y1, x2, y2, and then I just plug into this formula, y'all. So I am left with -3 plus 5 divided by 2, comma, 1 plus -6 divided by 2, comma. And so -3 plus 5 is going to be a positive 2 over 2. And then 1 plus -6 is going to be a -5 over 2. And so I would just reduce this to be 1, comma, -2.5, -2.5. All right, and that is where my midpoint lies, okay? All right, here it wants us to find the perimeter of the triangle STU. So we have to remember that we can count our sides that are horizontal and vertical, but if we have a side that is diagonal, we have to either A, apply the distance formula, or B, apply Pythagorean Theorem. And so I'm going to choose to apply Pythagorean Theorem here just because I feel it's a little easier, but you may use whatever formula you feel. So we need to count our sides first. So 1, 2, 3. So this side is 3. 1, 2, 3, 4. Side UT is 4. And then we're going to apply our Pythagorean Theorem. So Pythagorean Theorem is a squared plus b squared equals c squared. And what we have to remember is our A and B are our flat sides, and our C is our slanted side or our longest side. All right. And so now I go ahead and plug in. So I'm left with 3 squared plus 4 squared equals c squared. 3 squared is 9, 4 squared is 16, equals c squared. And so then 9 plus 16 is 25 equals c squared. And then in order to cancel out the squared, you do a square root and you get that c equals 5. And so now we know that this side right here is a whopping 5, but we're not done because what this question was asking for is it was asking for the perimeter. All right. And so we have to remember that perimeter is just adding all the sides. So really all I'm doing is 3 plus 4 plus 5, which is going to end up being 12 units. Moving on to question 11, it asks us to find the perimeter of the parallelogram. And so here we're in the same boat, but we have to remember the rules of a parallelogram, all right? So if we're dealing with the parallelogram, we know 2 sides are parallel, or there's 2 sets of parallel sides, and then 2 sets of congruent sides as well, all right? So we are going to go ahead and count this out. 1, 2, 3, 4, 5, 6. And then same thing over here. 1, 2, 3, 5, 6. And so those are our opposite sides that are congruent, and therefore our slanted sides are also going to be congruent. And this right here is where you can either choose to break this parallelogram into a right triangle and then apply Pythagorean Theorem as well, or you can go ahead and just do the distance formula. I'm going to choose to apply Pythagorean Theorem because, like I said, I think it's easier. So what you do is you take one of your points, draw a line straight down to the base, and then you're going to count. All right, so 1, 2, 3, 4. We are left with a 4 here. And then now this side becomes a 3. And so now I'm left with a squared plus b squared equals c squared. And so I get that 4 squared plus 3 squared equals c squared still. And so 4 squared is going to be 16 plus 9 equals c squared. So we get 25 equals c squared, square root it to cancel out the squared, and I get that c equals 5. All right, and so then I know by the property that the other side is also going to be 5, and then I just have to add the sides up. So I add 5 plus 5 plus 6 plus 6. That's really 10 plus 12, which is going to equal 22 units. All right, let's flip over to the next page. Looking here at question 12, it's asking what the area of the parallelogram is. It gives us a formula of area equals base times height. Luckily, we're given that our base is 8.1 and our height is 5.2. So now all we have to really do is just multiply these. So we're doing 5.2 times 8.1. And guys, I'd highly recommend multiplying this out in your calculator. Don't do this by hand. And you will get that the area is going to be 42.12 units squared. And the most important thing here is that area, the units is always squared. Moving down to question 13, it says find the coordinates of the endpoint C, given that B is a midpoint of AC. So let's go ahead and just draw our diagram already. Our diagram is going to look something like this, with midpoint being B, and we're going to have a segment AC. We know that A is going to be at 3, negative 5, and we know that B is at 10, 4. And we're looking for C. And so guys, this is going to be that loop method. All right, but the most important thing to remember here, y'all, is that when we have a midpoint, it cuts the segment in half, which means that segment AB and BC are equal. That's what allows us to do this loop method. So I need to ask myself, what happens to get from 3 to 10? So what can I do to 3, addition or subtraction wise, to get to 10? And so 3 plus 7 would give me 10. And because B is a midpoint, I can assume that the same thing is going to happen that happened from A to B to C. So then I just ask, what is 10 plus 7? It is 17. And then now I move to the next one. I'm moving to my y values. So negative 5 to 4. What did I do to get from negative 5 to positive 4? So I'm going to end up adding 9. And so I can assume, y'all, that the same thing happens here, that I add 9. So 4 plus 9 is going to be 13. So now I can tell that my coordinates to C is at 17, 13. And that would be my final answer there. Moving on to question 14, ray EG is a segment bisector. All right, there's another hint right there, segment bisector. For segment DF, find the length of DE. So if we have a segment bisector, y'all, what we need to remember is a bisector cuts these segments in half, goes through a midpoint, which means that segment DE and EF are equal. And so, guys, this is going to be where we employ our part equals part. And so I get x minus 1 equals 2x minus 8. And then I start manipulating this equation to solve. I'm going to add 8 to both sides to cancel out over here. I am left with x plus 7 equals 2x. I'm going to subtract x. So I am left with x equals 7. But that is not what my question was wanting. My question was wanting us to find the length of DE. So now I apply this formula to formula DE, which is x minus 1. And then again, we said x is 7. So 7 minus 1 is 6. Therefore, segment DE is equal to 6. All right. Find the coordinates of point I on HJ so that it is 1/3 of the distance from H to J. And so, steps to partitioning, all right, there's 4 steps. It is find distance, and that is big minus small number. Then find fraction. In this case, y'all, the fraction's given to us. 3 is to do distance times the fraction. And then whatever we get there, the answer, we're going to add it to our small number. All right, so let's find the distance. Here we can just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my distance here is 9. 2, I said my fraction was given, which is 1/3. 3, we're going to multiply those. So 9 times 1/3. And so really we get 9/3, which just simplifies to 3. And then for step 4, y'all, to go ahead and add the answer that we just got to our small number. So we are going to do 3 plus -3, which is going to equal 0. Therefore, our point I partitions right here at 0. All right, let's head to the last page. All right, so looking at question 16, it says which of the following points gives the coordinates -3, 11. And so what we have to remember here, y'all, is that we are in an x, y plane, and our x means left to right, and our y means up and down. All right, and so we are talking that our positive x's are here, our negative x's, negative y's are down here, and positive y's up here. And so we have a -3 first, and we set our x's first, so we're going to go to the negative x side 3, which is going to be somewhere about right here. And then I'm going to go to 11, which is positive, so that tells me I'm going to go to the positive y's, which is up, and we hit somewhere right here at point A. Next one, some simple algebra here. We're going to go ahead and draw our line, add 18 to both sides. And then we are left with 3x/4, which is going to equal 30. You're going to multiply by the 4 here to cancel out there. You're left with 3x equals 120. Divide by 3. And you are going to get that x equals 40. All right, question 18. It says to give a real-world example of the following, example and drawing of the following. All right, so a real-world example of a plane. So I'm going to go ahead and go with a soccer field. All right, so I'm going to draw this. It's going to be terrible. And so that's my soccer field. All right, and so SOCCERFIELD. An example of a line, I'm going to go with the equator. And this one's going to be really hard to draw. And my equator is this little line going around the world. A line segment. That's a terrible example, but it's a baseball bat. All right, so we have a baseball bat. Now, a real-world example of collinear. I'm going to do beads on a necklace. So it could look something like that, maybe. Coplanar. Coplanar, I'm going to go ahead and say something like a classroom floor. And the reason I'm saying that is because it's coplanar, because it's going to have the small desk on here, which are the points. And then it's going to also have the checkered lines or the tiles, which is going to represent lines going throughout the classroom. All right. And then last but not least, probably the easiest one, a point. Let's go ahead and just match it up with the one across. A baseball, a basketball, all right, whatever you want to choose, softball. But yeah, those are real world examples of what we are dealing with, all right? So guys, that is all I have for your review today. I hope you enjoyed. I hope you at least copied this down. If you have any questions, please feel free to see your geometry teacher. All right, remember you have your test coming up this Thursday and Friday. Best of luck, y'all.